Hello everyone, welcome to this new discussion. Feel free to click on the subscription button below to subscribe to my channel. Click also on the bell below to get notification of all the discussion I will be releasing, and feel free to share the video with others.
I'm Luke. In this fundamentals video, I'm covering the anti-lock braking system. Applying the brakes too hard or on a slippery or icy surface may cause the wheels to lock, increasing the chance of the vehicle sliding and the driver losing control. Only tyres that are turning can steer the vehicle. Once the wheels are locked, steering is lost. The anti-lock braking system, or ABS, prevents the wheels from locking and allows the driver to maintain control, enabling them to steer around a person or an object safely. No matter how slippery the road surface is or how hard the brake pedal is applied, the wheels should never lock up. ABS was introduced for aircraft in 1929. These days, it comes as a standard safety system for most current model vehicles. The anti-lock braking system consists of a brake pedal, brake master cylinder, ABS control module, a hydraulic control unit or hydraulic modulator, and wheel speed sensors. When the ignition is turned on, the system carries out a self-test by briefly actuating the hydraulic pump, as well as checking communications. If a fault is detected, the ABS symbol will illuminate on the instrument cluster, and an audible warning may sound. Once the wheels start to turn, the wheel speed sensors send a changing frequency signal to the ABS control module. The frequency of the signal is relative to the wheel speed. Vehicles can use one of two types of wheel speed sensors: older style 3-wire and more recently 2-wire sensors. The ABS control module constantly monitors each individual wheel's rotation speed. When the brakes are applied and the control module detects a different rotational speed of a wheel or wheels, the ABS module sends a signal to the hydraulic modulator. From here, the hydraulic control unit actuates the shift valve solenoid. This modulates or decreases and increases the brake line pressure on the affected wheel, adjusting the braking force. This enables the wheel to keep rotating, allowing full control to be maintained until the vehicle comes to a complete stop or the brakes are released. Some ABS can modulate the brakes 15 times per second. There are two common types of ABS: 3-channel and 4-channel. The 3-channel system has independent valves for each front wheel and a common valve for the rear wheels. The shift valves are in series with the brake master cylinder and the brake circuits. There is a wheel speed sensor on each wheel. On a 4-channel system, there is a shift valve allocated to each wheel. Let's take an in-depth look at the hydraulic unit's components and its operation. The ABS unit contains the ABS control module, the shift valves and their actuating solenoids, and a hydraulic pump. The ABS control unit commands the solenoids to energise when requested. The shift valves open and close the brake fluid ports within the unit, and the hydraulic pump supplies the pressure to reactivate the brake. Here's an overview of the inside of a hydraulic modulator, looking at one wheel and one brake circuit. It contains an ABS control module, shift valve, solenoid, and a hydraulic pump. When the brakes are applied under normal driving conditions, pressure is applied from the master cylinder through the valve and straight through to the brake caliper. If the wheel speed sensor signal does not rapidly change, no signal is sent to the solenoid valve, leaving the valve in its normal position, and the coil is not energised. When a brake force is applied and a rapid decrease in wheel speed rotation is detected, the pre-configured threshold is reached, and the wheel speed sensor signal changes. The ABS control module detects this as a potential wheel lock, and a new signal is sent from the ABS control module to the hydraulic modulator. From here, the signal from the ABS control module energises a coil around the valve, causing the valve to slide and block the brake circuit from the master cylinder. This maintains the pressure between the solenoid and the brake circuit, even if the master cylinder hydraulic pressure rises. If the wheel speed sensor is still rapidly changing its signal due to decreasing wheel speed rotation, the ABS control module will increase the signal current to the solenoid, causing the valve to slide further along. A return passage opens. This reduces brake pressure to the brake caliper and stops the wheel from locking up. The wheel speed sensor will detect that the wheel speed rotation is increasing and signals the ABS control module to disable the signal to the solenoid valve. The solenoid will then de-energise and a new signal will be sent from the ABS module activating the hydraulic pump. The valve will return to its initial position, allowing the pump to increase the pressure into the hydraulic line. Brake pressure will never rise above master cylinder pressure. The valve rapidly opening and closing is the pumping pressure felt at the brake pedal by the driver. An indication of a failed ABS can include a warning light on the instrument cluster and/or an audible warning. There are also many DTCs that can set, indicating a fault in the system. That's the anti-lock braking system. Understanding how the system works will help with diagnosis, and ensuring the system functions correctly could be a lifesaver. Thanks for watching. Bye for now.
Feel free to click on the subscription button below to subscribe to my channel. Click also on the bell below to get a notification of all the discussion I will be releasing, and feel free to share the video with others.